concentration of A over the constant of the change in time. That's the rate of disappearance of A, and this would come out to be a negative number because it's being used up. But now to get the rate of reaction, you just put in that coefficient there.
So those are coefficients then?
That's
Okay.
the coefficient from the balanced equation. In other words, I wrote the general thing where I said the rate of reaction, and I didn't write this whole thing out, but I really should. I'm going to use Rxn for reaction.
I see.
So that's the rate of reaction. That's the same number whether we talk about the rate of disappearance of A or the rate of formation of C. For instance, I'll do D. And this rate of formation of D would be delta concentration D. And notice if I wanted to go from the rate of disappearance of A to the rate of formation of D, I would say I'm looking at the balanced equation, that's why I look over there. That's going to be equal to rate formation of D. And I did the, yes?
The rate of reaction isn't negative.
What happens, as I said, this book uses, and most books do this, they say the rate is always going to be a positive number. So this number right here, the change in A with the change in time comes out negative. But then notice he gave you a positive number here for that, because the definition says rate disappearance, I have to put all these words in here. And you put the minus sign in here arbitrarily for reactants, you don't put it in for products. And now this, since you're using up reactants, is going to have a negative number, two negatives make a positive. So they just arbitrarily, well, they don't arbitrarily put it in, they put it in to make the rate number come out to be a positive number. And the only reason I keep mentioning this is one of the problems that I think I assigned the problem set where once you go from rate of one thing, I forget which ones I assigned this year, but nobody's asked me about them, so I assume everybody's get it. But somebody always, when they get to that problem set, since nobody had it, maybe I didn't assign it, but there in that homework set, they expect you to put the minus signs in for the reactants, the ones that are disappearing. So when you're answering that homework set problem, if I assigned it, you'd put it in as minus 6.2. But that's for that homework set. And I forget which book they were working from when they wrote this problem set up. But it was one of the other textbooks that used the sign of the rate of reaction to say whether something's disappearing or something's appearing. Okay. Whereas this book, and as I said, most of the books always say rates, regardless of whether it's appearance or disappearance, should always come out to be a positive number. So when they talk about the rate of formation, I'll pick one of these things. This was of A, of course. This will be, which one should I pick? It doesn't matter. C, it's going to be equal to, now as this starts being produced, the final number is always going to be bigger than the initial number, so this comes out positive. No sign here, it's a positive number. That's what you have to do to be consistent with what's being done in the textbook. Okay. Any other questions about that?
So like that's just the answer? Like
Well, I didn't finish the answer. What does it say? found to disappear at the rate of 6.2 times 10 to the minus 4. What is the rate of reaction at this point? So what you're going to do is take rate reaction. Oh, I said I was going to abbreviate it, and I gave you abbreviation, so I can say it sometime in here. Oops, I put that M, I didn't do my formatting too well. Let me do the formatting right. Okay, so all I did was divide by 2.
Right.
Now what's the next question? What is the rate of disappearance of B? Now I'm going from, and I'm going to actually write this out because I did this the last time with units, and you don't really have to do with units. All you're doing is looking at the mole ratio, but it says 6.2 times 10 to the minus 4 moles A per liter seconds. That's a multiplication sign there. It's a big dot. Okay. And so the only reason I'm doing this, now you can say, okay, I'm looking at my balanced equation. There's 1 mole of C per 2 moles of A. And now you get the rate of what?
Disappearance.
Formation of C.
Oh, formation of C.
And it's going to be so that's the rate of formation of C, which is what you want to get. Now notice, oops, I'm sorry, I did the formation of C. Did I get in the wrong? I guess I answered a question you didn't ask. He said, what's the rate of reaction? What is the rate of disappearance of B? Okay. And there's 1B per 2A. And notice when you just look at the units, molarity per second, that doesn't really tell you what you're talking about, but if you expand this out like this, where you convert the molarity, it'd be moles of B per liter. Moles, so this would be moles of B per liter. This would be moles of C per liter. That's the molarity you're talking about. Now if I want to take this number and go to the rate of the reaction, it's going to be, and the coefficient of B is what?
1.
1. So it's notice when I did it for A, for the rate of reaction, I got this number. When I did it for B, I got exactly the same number. And the next thing he says, let's do the last one. What is the rate of formation of D? I'm going to start with moles of A, liters, seconds, times, that says 3D per 2A. So now I've got moles per liter of D, and I can do it by 3 halves, so it's 3.1 times 3. Notice when you write it molarity like that, you don't really see which thing you're talking about. You expand it out, or you say moles per liter of A, moles per liter of C, D, etc. You see what you're talking about better. So in a sense, it's always, I said I don't really care if you don't put in the units in the middle, as long as you show me the right numbers. But if you put in the units, it keeps track of what you're doing. Now if I want to use this number to calculate the rate of reaction,
So you're using the formation of D to calculate the rate of reaction.
Right, I'm going to use the rate of formation of D to calculate the rate of reaction. The coefficient of D is what?
3.
3 times. Notice, whether you're talking about D, whether you're talking about, and I forgot which one this was because I didn't put it in units, but when we go back here, this is D, and this one, wherever I got it, was for A. You get the same number for the rate of reaction for each of the reactants and products.
Okay.
That's why they talk about the rate of reaction as being different than the rate of formation or the rate of disappearance or anything else. Yes?
For that second one, it should be moles of A, right?
Where are we?
The one right, it says moles of B.
Yeah, that one.
Oh, this one right here, B. Oh, what did I do here? Started with moles of A. Right, my units canceled out. In other words, I want to cancel these units out, right?
Yeah.
There we go.
Okay.
Now we're looking. So it came out to be, and as I said, this would be for B because that's what we got here, be moles of B per liter per second. Then when I convert it to the reaction rate, I just divide it by 1, and this is molarity per second. That's why they leave it general like this, because you have to stop and think which one they're talking about. When you're doing formation or disappearance and things, then you have to relate it to the specific coefficients in the balance equation. You do get different numbers based upon the stoichiometry of the reaction. But the rate of reaction always comes out the same no matter which substance you're following.
When you're calculating the formation of D, do you have to use A or can you use B?
You can use A, B, or C.
Oh, okay.
Whichever one you know. Because you have the mole ratios between this and this, this and this, this and this.
Okay.
In other words, going between any reactant or product, it's simply using the mole ratio that you see in the balanced equation.
Okay.
But, and same thing, you're still using the moles, but you're not using the mole ratio. In other words, when you're doing this calculation right here, it's not a mole ratio, you're just dividing it by the coefficient of the particular substance. I wrote the general equation way back when, that's sometime. I use this equation a lot, but basically I can say rate of reaction I'm just going to say disappearance of A. Equation there. It's equal to 1 over B, rate disappearance of B. It's equal to 1 over C, rate formation of C. And what I said is this number is equal to this number is equal to this is equal to this. You just calculate it differently each time. Yes?
Shouldn't the first two be negative?
Remember I said your book is using what? Always positive numbers for the rates. And so when he talks about the rate of disappearance of A or the rate of disappearance of B, he's going to put in for disappearance, he's going to put a minus here, and this number is a minus. The two minuses make the rate a positive number. And I said when you're answering that one question, if I assign that homework assignment on the web page, or if I didn't assign it, you do it just for practice, there they'll want you to put the minus signs in for reactants and leave the rate without the minus sign for products. Otherwise, they're going to say it's wrong.
Okay.
Okay. I don't know if I assigned it to anybody do any of those problems where you had to put in the minus signs to get the right answer.